after a short break, we will start our question number 5C. Up to question number 5B, we already completed now. So let's start question number 5C in this question paper. Question number 5C. If A is equal to 1 0 0 2, then find the eigenvalue of A square and A inverse. So question number 5C. If A is equal to 1 0 0 2, then find the eigenvalue of A square and A inverse. This question asking 2 marks. Again, this is a triangular matrix, so you can see eigenvalues are directly, you can write down the eigenvalues are 1 and 2. Okay, and using the definition or using the method, you can also find the eigenvalue. The characteristic equation of A is A minus lambda I is equal to 0, 1 minus lambda 0 0 2 minus lambda is equal to 0 determinant. So 1 minus lambda into 2 minus lambda is equal to 0. So the eigenvalues of A are lambda 1 is equal to 1, lambda 2 is equal to 2. So the eigenvalues of A square and lambda 1 A square are lambda 1 square, that is equal to 1 square, and lambda 2 square, that is equal to 2 square. The eigenvalues of A inverse are 1 upon lambda 1 and 1 upon lambda 2. So 1 and 1 by 2. Because of we use this theorem that if we have triangular matrix, so eigenvalues of A is equal to lambda 1 and lambda 2, then eigenvalues of A raised to k are lambda 1 raised to k and lambda 2 raised to k. So exactly we use that theorem. The eigenvalues of, we want to find here eigenvalues of A square. So that is exactly the eigenvalues of A square are lambda 1 square and lambda 2 square, and lambda 1 and lambda 2 are 2, 1 and 2. So 1 square and 2 square, so 1 and 4. Okay, and similarly the eigenvalues of A inverse that is equal to 1 upon the eigenvalues of A. So lambda 1 and lambda 2 are eigenvalues of A. So the eigenvalues of A inverse are 1 upon lambda 1 and 1 upon lambda 2. So 1 and 1 by 2. So here the complete this question, and this question asking 2 marks. Next question number 6. Question number 6A, first part. Let R3 have the Euclidean inner product. Use the Gram-Schmidt process to transform the basis S is equal to 1 1 1 0 1 1 0 0 1 into an orthonormal basis. So here we use Gram-Schmidt process to transform the basis S is equal to 1 1 1 0 1 1 0 0 1 into orthonormal basis. So let U1 is equal to 1 1 1, U2 is equal to 0 1 1, and U3 is equal to 0 0 1. First we convert these three vectors into orthogonal vectors. Okay, and then from orthogonal to orthonormal, that we know already, that we should divide it by norm of each vector divided by its norm, right? So first we convert these 3 vectors into orthogonal vectors, and that is the main process. And for that we use some formulas that starting with V1 is equal to U1 is equal to 1 1 1. Now we want to find V2 such that inner product with V1 and V2 is equal to 0. Okay, so here is the formula that V2 is equal to U2 minus inner product U2 V1 upon norm V1 square into V1. Inner product U2 V1 upon norm V1 square into V1. So inner product U2 V1, that is equal to 0 1 1 into 1 1 1, that is equal to 0 plus 1 plus 1, that is equal to 2. And norm V1 square, is equal to 1 plus 1 plus 1, that is equal to 3, because v1 is equal to 1 1 1. So norm v1 square is equal to under root 1 plus 1 plus 1 equal to 3. And now we use this formula, v2 is equal to u2 minus inner product u2 v1 upon norm v1 square into v1. So put all the values in this equation, all the values in this formula. v2 is equal to u2 minus inner product u2 v1 upon v1 square into v1. So u2 is 0 1 1 minus inner product u2 v1, that is 2 by 3. Okay, sorry, inner product u2 v1 is 2, norm v1 square is 3. So 2 by 3 into v1, that is 2 by 3 into 1 1 1, that is equal to minus 0 minus 2 by 3. So minus 2 by 3, 1 minus 2 by 3, that is 1 by 3, and 1 minus 2 by 3, that is 1 by 3. So minus 2 by 3, 1 by 3, 1 by 3, we will get v2. Now we want to find v3, and the formula of v3 equal to u3 minus just see last equation in this screen. v3 is equal to u3 minus inner product u3 v1 upon norm v1 square into v1 minus inner product u3 v2 upon norm v2 square into v2. So inner product u3 v1, that is equal to 0 0 1 into 1 1 1, that is equal to 0 plus 0 plus 1, that is equal to 1. Inner product u3 with v2. Now what is our u3? u3 is 0 0 1 and v2 is minus 2 by 3, 1 by 3, 1 by 3. So inner product u3 v2 equal to 0 0 1 minus 2 by 3, 1 by 3, 1 by 3, that is equal to 0 plus 0 plus 1 by 3. Just simply dot product, we use just simply dot product. So 0 into minus 2 by 3 plus 0 into 1 by 3, that is 0 plus 0, plus 1 into 1 by 3, that is 1 by 3. So 0 plus 0 plus 1 by 3 equal to 1 by 3. Norm v2 square equal to under root, if v2 is equal to x1 x2 x3, so norm v2 square is equal to x1 square plus x2 square plus x3 square, and v2 is minus 2 by 3, 1 by 3, 1 by 3. So that's why norm v2 square is equal to 2 by 3 minus 2 by 3 square plus 1 by 3 square plus 1 by 3 square. So that's why norm v2 square is equal to 4 upon 9 plus 1 upon 9 plus 1 upon 9 equal to 6 upon 9 equal to 2 by 3. And put all these values, inner product u3 v1, inner product u3 v2, norm v1 square, norm v2 square, all these values put in the equation, in the last equation. We have v3 is equal to u3 minus inner product u3 v1 upon norm v1 square into v1 minus inner product u3 v2 upon norm v2 square into v2. So v3 is equal to 0 0 1, that is u3 minus u3 v1, inner product u3 v1 is 1 and norm v1 square is 3. So that's why 1 by 3 into 1 1 1, that is v1, you can see. Okay, now inner product u3 v2, inner product u3 v2 is 1 by 3 and norm v2 square is 2 by 3. So 1 by 3 upon 2 by 3 into v2. v2 is minus 2 by 3, 1 by 3, 1 by 3. So minus 2 by 3, 1 by 3, 1 by 3. 0 0 1 minus 1 by 3, 1 by 3, 1 by 3 minus 1 upon 2, 1 by 3 upon 2 by 3, that is 1 upon 2 into minus 2 by 3, 1 by 3, 1 by 3. Solving this equation, we will get 0 minus 1 by 3. So 0 minus 1 by 3 minus 1 by 3, 0 minus 1 by 3 minus 1 by 3, 1 minus 1 by 3, that is 2 by 3. So minus 1 by 3 minus 1 by 3, 2 by 3, first vector plus second vector as it is plus 1 by 3 minus 1 by 6 minus 1 by 6. So now add this two vector, minus 1 by 3 plus 1 by 3 that is 0, minus 1 by 3 minus 1 by 6 that is minus 1 by 2, and 2 by 3 minus 1 by 6 that is 1 by 2. So this v1, v2, v3 are orthogonal vectors. This v1 1 1 1 minus 2 by 3 1 by 3 1 by 3 and 0 minus 1 by 2 1 by 2 is orthogonal basis. Now actually we want to find orthonormal basis. We convert the given basis into orthonormal basis. So what we have to do here, we already this process before some time. So we find norm of each vector. Norm v1 is equal to under root 3 under root 1 plus 1 square plus 1 square plus 1 square. So that is norm v1 is equal to under root 3. Norm v2 is equal to under root 4 by 9 plus 1 by 9 plus 1 by 9. So that is exactly under root 2 by 3. Norm v3 is equal to under root 0 square plus 1 by 4 plus 1 by 4. So that is 1 by root 2. So we are dividing v1, v2, v3 with its norms. So the required orthonormal basis is v1 upon norm v1, v2 upon norm v2, v3 upon norm v3. So the required orthonormal set of bases is 1 by root 3, 1 by root 3, 1 by root 3, minus 2 by root 6, 1 by root 6, 1 by root 6, 0 minus 1 by root 2, 1 by root 2. Question 6a, second part. This question asked in 3 marks. Let V be the inner product space of all real valued continuous functions on 0 to pi by 2 with inner product fg is equal to integration 0 to pi by 2 fx into gx dx. Find the angle between cos x and sin x. Find the angle between cos x and sin x. Now what is the formula for angle between two functions, two real valued continuous functions? Here is the formula. You can see if theta is the angle between fx and gx, cos theta is equal to inner product fg upon norm f into norm g. So actually we want to find norm f, norm g and inner product f with g. Okay. So for that, first of all we have fx is equal to cos x, gx is equal to sin x. So that's why we find first of all fx into gx, that is cos x into sin x. Some simplification there, that we multiplied 2 and divided by 2. So 2 sin x cos x divided by 2. 2 sin x cos x is sin 2x. So sin 2x divided by 2. So now we have fx into gx is sin 2x divided by 2. Now we want to find inner product f with g, that is equal to integration 0 to pi by 2 fx into gx dx using the definition equal to 1 by 2 0 to pi by 2 sin 2x, because fx into gx is sin 2x by 2, 1 by 2 will be outside from the integration, and integration of sin 2x is minus cos 2x by 2, and our integration is from 0 to pi by 2. So instead of x, first of all we have to put pi by 2. So minus cos pi is minus 1. So 1 minus, and minus minus plus. So 1 plus 1, 1 by 4 into 1 plus 1, that is 2 by 4, that is 1 by 2. So inner product f with g, we will get 1 by 2. Now we want to find norm f square. Okay. So norm f square is equal to inner product f with f. So 0 to pi by 2 fx into fx dx, that is equal to integration 0 to pi by 2 sin square x dx equal to 1 by 2. Sin square x can be written as 1 minus cos 2x divided by 2. So 1 by 2 will be outside. Integration from 0 to pi by 2 of 1 minus cos 2x dx equal to 1 by 2 x minus sin 2x divided by 2 from 0 to pi by 2. So 1 by 2 into pi by 2, it is equal to pi by 4, because instead of x, whenever we put pi by 2, sin pi becomes 0 and 0 sine 0 is also 0. So just instead of x we have to put pi by 2, and whenever we put 0, that is 0. So pi by 1 by 2 into pi by 2, that is pi by 4. Similarly, we can find norm g square. Here is the norm g square, that is equal to inner product g with g equal to 0 to pi by 2 integration from 0 to pi by 2 gx into gx dx, that is equal to integration from 0 to pi by 2 cos square x dx. So cos square x can be written as 1 plus cos 2x divided by 2. So 1 by 2, 0 to pi by 2, 1 plus cos 2x equal to 1 by 2 x plus sin 2x divided by 2 from 0 to pi by 2. So equal to 1 by 2 into pi by 2 equal to pi by 4. So hence norm f square is equal to pi by 4. So norm f is equal to root pi by 2. Norm g square is equal to pi by 4. So norm g is equal to root pi by 2. If theta is the angle between fx and gx, I already explained that theta is the angle between fx and gx, where fx is cos x, gx is sin x, then cos theta is equal to inner product f with g upon norm f into norm g. Now we all three parts, we have inner product fg, we have norm f square and norm g square, that means norm f and norm g. So put these three values in the formula. Cos theta is equal to inner product fg upon norm f norm g. We find that inner product fg is 1 by 2, norm f is under root pi by 2, norm g is also under root pi by 2. So 1 by 2 upon under root pi by 2 into under root pi by 2, that will become 2 by pi. So cos theta is equal to 2 by pi. So theta is equal to cos inverse 2 upon pi. So here is the complete this question. And the next question, question number 6b, first part.